G'day everyone, how are you going? Welcome back to another video. Today, complex numbers. This is really a review. So if you're in Spec Year 12, a lot of this you would have done last year, and hopefully a fair part of it you remember. I'm only going to move real quick. I'm hoping that this is a review for you. So what do we need to know about complex numbers? Well, they come around from this issue here. If we try and take the square root of a negative number, that's not going to work. We can't have a negative number and take the square root of it. So what we need to do is come up with something else that we can put in place of it. So this is our definition of what an imaginary number is. Okay? Square root of -1, we call it I. Having known that, and you'll see this comes about when you're using the quadratic formula. You remember that bit, square root of b squared minus 4ac? When that comes negative, you're in this situation. And that also means that that's where you're going to get two complex conjugates as answers, but we'll get to that in a minute. So, square root of -4, what we need to see here is that this is really the square root of 4 multiplied by the square root of -1, and then we use this idea here, and we can write 2i. Okay? Similar fashion here, I could just jump straight away and write 10i because I know that's going to split up in a similar sort of way, and I'll end up with 10i as my answer there. When we're writing our complex numbers, we often refer to rectangular form. Okay? Rectangular form is this a plus bi idea. Okay? So the real part of it is going to be the a part because there's no I after it. It's just a number. So that's the real part. And the b part, because it has an I after it, that's going to be our imaginary part. Okay? So when a question says, give your answer as a rectangular form, this is what you're looking for. We get into very quickly, actually, just the next lesson or so, we'll get into doing it in different forms as well. Okay, there's a couple of different ways we can write it. Polar form is a very common form. I'll do a video on that one, converting from one to another. So our rectangular form of a complex number, remembering this idea here. Once we've got that sorted, let's have a look at our graphing of it, because when we graph something that we're generally used to, a quadratic equation or linear or whatever, we've got x and y. But when we're graphing things that are complex numbers, x and y are both real axes. So that's not going to work because I need to be able to graph my imaginary part as well. So my real and imaginary replace my x and my y. Now if you forget how they go or what order they go, the thing to remember is that in your rectangular form, you put the real number and then the imaginary number. When you're writing coordinates, you would write the x number and then the y number. So this order here is the same as this order here and the same as the order of x and y. Alright, so if you kind of forget which way they go, that's the easy way to remember. It's the same as a Cartesian coordinate, just replace real for x and imaginary for y. So we get this idea. It looks exactly the same as the Cartesian coordinates except for the naming of it. The numbering, the spacing, everything's the same. There's nothing different there. So let's just graph one up. Let's graph up a point, say, about here. We do exactly the same, just like we would with x and y. Nothing different there. This one, I'm going to say that that's going to be 4. I'm going to say that that one's going to be 2. So that point there, if I was to write it in rectangular format, we put the real one first, then the imaginary one. So that point would be the point 4 plus 2i. Okay, 4 plus 2i would be that point there. Now then when we look at this idea of complex conjugate, and remember I said you often get that because this comes up in the quadratic formula, and the square root part in the quadratic formula is plus and minus. So you'll get an answer with a positive imaginary number and an answer with a negative imaginary number. So the complex conjugate of this one is where we change the imaginary part to a negative. So I'll do it in green up here. This point here would actually come down to this point right here, where it would become at -2. So the complex conjugate of this point here is this one down here. So it would be 4 take 2i would be the complex conjugate. Now another way of seeing that is that whatever this point is reflected in the x-axis or the real axis. So it just takes it from here, brings it down here. We don't change the real component at all. The real stays exactly the same. It's just the just the imaginary part that actually changes. Hope this video has helped. It was very quick through here. There's lots of other spots you can get information about this. We do move on a lot further with this complex idea, so do keep up to date with what you're doing there. Hope this has helped. Catch you later.